All right, today we have 2.2 graphs of linear equations for Algebra 2. All right, so our objectives are to identify the slope and the x and y intercept of a line, to interpret slope as a rate of change, to graph the linear functions, and to convert linear equations from standard to slope-intercept form. Lots of good stuff. All right, first up, a linear function. Okay, a first-degree polynomial function whose graph is a line. So a linear function is always a line. Okay, notice it's f of x equals negative 2x plus 1 or y equals negative 2x plus 1. Hopefully you remember this first-degree polynomial. It means your variable. You just have a variable to the power with no power on it. Okay, the power is never given. That's what that first-degree polynomial means. Standard form of linear functions is ax plus by equals c. To note, it's important to note, a is positive and a whole number. Okay, in correct form, a is always positive and it's going to be a whole number. So no negatives, no fractions here. Okay, when it comes to graphing, we've got 3 steps we can kind of use. We can find the x by letting y equal 0. We can find the y-intercept by letting x equal 0. Need to choose another value to solve. And then 3, graph the 3 points. Remember I said 3 is always key. 3 is the minimum I will accept for a good graph. Well, 3 is really the minimum anyone will accept. All right, so let's look at example 1 and start by graphing. It says graph 2x plus 3y equals 6. So this is indeed in standard notation, right? So let's think about that. ax plus by equals c. So what's our a value equal? 2. Good. What's our b value equal? Excellent. 3. What's our c value equal? Good. It's 6. Now, what does that tell you right now? Nothing, per se. But we can use this to find our graph, okay? So we're going to find the x-intercept by letting y equal 0. So we're going to say ax plus by, I'm going to put a 0 there, equals, pardon me, let's go back to the actual equation and solve it. So 2x plus 3y, so that's where we're going to put our 0, equals 6, okay? So that's where our y equals 0. If I could talk and not get tongue-tied. So then that leaves us with 2x equals 6 divided by 2, x equals 3. But our y is 0, so we have a coordinate. We have an ordered pair here. It's 3, 0 that we can graph. All right, on the next one, we're going to find our y-intercept by letting x equal 0. So we have 2x, okay, well we're going to have that be 0, plus 3y equals 6. That leaves us with 3y equals 6, divided by 3, y equals 2. Okay, but again, we have an ordered pair because we let x equal 0, and we just solved for our y, so this ordered pair is 0, 2. And we need one more. We can pick our own point wherever we want. Okay, so we had 3, 0, 0, 2. Maybe you just want to pick 1. Or if you're going to have to add them to 6, maybe you want a number that's going to add to go into 6. It really does not matter. Okay, so I'm going to pick negative 3 for my x value. Okay, so I'm going to say, well, let's let x equal negative 3. So I'm going to do 2 times x, so negative 3, plus 3y equals 6. So 2 times negative 3 is negative 6, plus 3y equals 6. So I'm going to add 6 to both sides, have 3y equals 12, divide by 3, and y equals 4. But again, I have my ordered pair because I said x equals negative 3. So this is negative 3, 4 for my ordered pair. And then I'm ready to graph them. So 3, 1, 2, 3, 0, 0, 2, and negative 3, 1, 2, 3, and 4. 1, 2, 3, 4. Okay, recall that this is a line or a function, right? We're graphs of linear functions. So we need to make this a line and connect the points and put our arrows on both ends. Okay. All right, so then we have a box to help us with finding the x-intercept and finding the y-intercept. So it's telling us set y equal to 0 and solve for x, set x equal to 0 and solve for y. That's exactly what I had up here in our graphing. So this is just helpful. There is a little shortcut here, if you remember it, that the x-intercept is going to be c divided by a, comma 0, where the y-intercept is going to be 0, comma c divided by b. I will tell you, I don't ever remember those, but it's easy enough to solve that I can just solve it, right? You're always canceling one out, and then you can do it really quickly, even in your head. The other thing you can note is to find your slope. Okay, there's a formula for that, but slope is equal to negative a over b. That's one that I should remember, but again, I don't because we don't use standard notation. Like, I don't use it enough in teaching it, so I just don't remember it. But one day it may be something that you use a lot and you'll remember. All right, let's look at example 2. We want to graph negative 3x plus 4y equals 1200 using the x and y intercepts again. Okay, so that's going to be key. You know, we're going to follow those directions. So we're going to have negative 3 times 0 plus 4y equals 1200. And then we're going to have negative 3x plus 4 times 0 equals 1200. Okay, so really quickly we put 0 in for x in one equation, 0 in for y in the other. So that leaves us with, because negative 3 times 0 just leaves us with 4y. So we divide by 4 and we have y equals 300. So this is 0, comma 300. And in the other one, pardon me, just dropped my book. So in the other one, 4 times 0 is 4. So we're just going to divide by negative 3. So x is going to equal negative 400. So our ordered pair here is negative 400, comma 0. All right, and we need to pick one more point. Always pick a third point. So let's go with 400. I got negative 400. Let's go with a positive 400. So when x equals 400. So I'd have negative 3 times 400 plus 4y equals 1200. So negative 3 times 400 is negative 1200 plus 4y equals 1200. So if we add 1200, then we would get 4y equals 2400, right? Divide by 4, y equals 600. So our ordered pair here is 400, comma 600. All right, so on my graph, it's not numbered, but we're going to assume, okay, that each one kind of goes up by 100 because I couldn't find those graphs. So it's going to be 0, 300, 100, 200, 300, negative 400. Oh, I'm sorry. I meant to go up, not over, because it's 0, and then up 300, 1, 2, 300. And then negative 400, 1, 200, 300, negative 400, 0. And positive 400, 1, 2, 3, 400. Positive 600, 1, 2, 3, 4, 5, 600. All right, and we have a line, so we also need to connect our points. Okay, that third point on these graphs, like, in doing them, again, it kind of seems maybe unnecessary, but when we're doing them a lot, that third point will help us see if we're solving our equations correctly or incorrectly. Because sometimes I've seen people that have had like a point up here, or like this point would have been over here, and the line would have went in a triangle. It should never do that. It's a linear function, so it's going to make a straight line every time. And that third point helps you make sure you've solved it correctly. All right, let's look at slope then. Slope is the steepness or incline of a line. It measures the rate of change, always. It is a ratio of the vertical change, or the rise, to the horizontal change, the run. So all kinds of different ways that you see slope here. Okay, so remember, slope is m. We can write it as rise over run, our y2 minus our y1 value, divided by our x2 minus x1 value, the change in y over the change in x. We have positive slope that goes uphill, negative slope comes downhill, zero slope is horizontal, and slope is undefined is a vertical line. Okay, if you have a graph, we have it marked how you can find the slope on your graph from 2 points. Remember, you check your rise or your change in y, and you write that as your x, or your change in x. Okay, so all those different ways that you have seen this before. Okay, so let's look at example 3. It says find the slope of the lines in examples 1 and 2. Well, we already erased those, didn't we? So you can flip your paper over. I, however, cannot flip my paper over. So good job for me there. That's helpful. So I'm going to put my book down here for a minute so we can look at their example. Well, let me get their example 1. Okay. Doesn't want to get, there we go. All right, so example 1. Let's see if I can see it on here. So we want to find the slope. So from this point on x to this point here. It doesn't have to be on x and y. Remember, just finding the difference between those two. Okay, so it looks like we go up 2, and we're going left 3, but it's a negative because we're going left. Okay, so our slope for example 1 would be m equals negative 2/3. Okay, so m for example 1 would be negative 2/3. Okay, let's look at example 2. I didn't think this through very well in my preparing my notes here, I guess. All right, so let's look at example 2. So we've got 2 points on there really handy. All right. Okay, so example 2, we're going up, looks like 1, 2, 3. And then how we're going right is 1, 2, 3, 4. Both of them are positive. So our example 2 slope is 3/4. Okay. All right. The paper wanted to run away. All right. So how about example 4? It says find the slope of the line passing through -8, 5 and 4, -3. We can't use the graph, right? We can't use this graphing strategy that we just used, but we can use this, one of these, right? Like this one right here. Or it's these two really. The change in y over the change in x. And the order which you do it doesn't typically matter, or it doesn't really matter, as long as you keep them in the same order. Okay, so our slope equals, right, y2 minus y1 over x2 minus x1. So this is going to equal We circle our y's first, 5 and -3. So 5 minus -3 over -8 minus 4. So again, 5 came first, so -8 had to come first, keeping them in that order. 5 minus -3 is the same thing as plus, so we have 8. -8 minus 4 is -12, and then we can reduce that, right? -8 twelfths reduces to -2/3 equals the slope. Okay, so using the other notation. All right, example 5. A 2-stage model rocket was launched and its velocity graphed. Determine the rocket's acceleration during the first and second stage of its flight. Okay, what they're calling that is right here. You see how it bends, right? So this is its first stage, and then this was going to be its second stage of flight. All right, and we want the rocket's acceleration. What is acceleration? I mean, we've been talking about y equals mx plus b, linear equations, right? Linear functions. Acceleration is the slope, because slope is the rate of change. Just like speed, right? It's a rate of speed. It's the rate of change as well. It's a rate. Okay, so anytime we're looking for a rate of any kind, we're looking for the slope. All right, so what is the slope of the model rocket? Okay, so again, you might pick out 2 points. So I've got 0, 0 here, and looks like 0.3. Yeah, 0.3, 180. So my first stage. Okay, so I'm going to use the points 0, 0 and 0.3, 180. Okay, so my slope, m, is going to equal 180 minus 0 over 0.3 minus 0. It's a really nice one to do, right? I like it. Okay, so this equals 180 over 0.3, which is equal to 600 in the first stage. All right, then let's look at my second stage. All right, I can use the same starting point, that 0.3, 180. I can use that same point. That's the starting point for my second stage. And I'm going to use 1.4 because it intersects nicely there. So my other point is going to be 1.4 comma 400. Again, I'm looking for nice places where they intersect. I don't want to use this place because it doesn't intersect well. All right, so then setting up my slope, slope is going to be equal to 400 minus 180 over 1.4 minus 0.3. All right, so 400 minus 180 is 220. 1.4 minus 0.3 is 1.1. And so now my slope is 200. There. Okay, so but it doesn't ask for slope, right? I do need to put this into an answer like the problem is asking. So it's acceleration, and it is, we can look here and see, right? It is meters per second. Okay, meters per second. And that is also by, that's its velocity. And so it's also how much time. So meters per second is meters per second squared. So its acceleration here equals 600 meters per second squared. And its acceleration in stage 2 equals 200 meters per second squared. Okay, again, this is looking at these, how I got that unit is our velocity is meters per second. Our time is over seconds. So that's equivalent to meters per second squared. Okay, one more thing we've got to get to here. Convert standard form that ax plus by equals c to function notation, y equals mx plus b, or the f of x equals mx plus b. Okay, I would take either of those, but let's try to get it into the f of x. All right, so all we're doing, right, to get it in function notation, we have the y by itself. I'm going to change up colors here. We have the y by itself, so we need to get the y by itself here. So we're going to subtract ax from both sides, and we'll have by equals c minus ax. We're just balancing a literal equation at this point. We have b times y, so we're going to divide by b to get y by itself. So y equals, all right, we're going to say cb minus a over bx. Sorry, c over b minus a over bx. Okay, does this look like function notation? Good. Hopefully you caught that. It's not quite because our x, right, is supposed to be in front. So we would need to write it as y equals negative a over b x plus c over b. Or you can write it as f of x equals negative a divided by b x plus c divided by b. Okay. Very nice. The cool thing from this that you can tell then is that your slope is equivalent to negative a over b, and your y-intercept b is equal to c over b. So once you have that, those are good conclusions that you can draw, right? Because there's the slope and there's the y-intercept. Okay, so example 6, let's put this into action. We're going to write 3x plus 2y equals 8 in function notation and use its slope and y-intercept to graph the function. All right, so we're going to do the same thing. We're just going to convert this to function notation or slope-intercept form. All right, so subtract 3x from both sides. So I'm going to have a positive 2y equals. Let's counteract what we did earlier. Let's put the negative 3x in front and then just add 8. Go ahead and take care of that first off. Divide by 2. So y equals negative 3 over 2x plus 8 divided by 2 is, good, 4. So our slope is, very nice, negative 3/2. And our y-intercept is, very nice, 4. Okay, now we're ready to graph it. So we're going to graph our y-intercept first at 4. 1, 2, 3, 4. And then we're going to use our slope, negative 3 over 2. So I'm going to go down 3, 1, 2, 3, over to the right 2, positive. I'm going to go up 3, positive, 1, 2, 3. I'm going to go negative 2. 1, 2, 3, negative 2. You can do as many of these as you want, but you need at least how many? Good, at least 3 points on that graph. At least 3. All right, that's it. Have a great night. I will see you tomorrow.